All right, we're wrapping up Chapter 5 with 5-8 on quadratic regressions. If you're going to look at this lesson online, you should practice by doing a quadratic regression. So you're going to want to put these two data sets, real diameter versus real length, and I'm guessing it's movie reel, film reel, but anyway, you're going to use that later to practice yourself. So what we are going to do is use quadratic models to analyze and predict. Quadratic model is a quadratic function that represents a real data set. Models are useful for making estimates. So we did linear regressions. We took two data sets, put it into our calculators, did a linear regression on it, and it gave us an equation, which is basically our model. So then we can make predictions for data that we don't have. And as it says, that's just what it says right here. We can do the similar thing for quadratic models as well, using a quadratic regression. And our graphing calculators have quadratic regression functions on them. So we're going to do it in a similar way. We're going to put data into the calculator, use the quadratic regression function, and it's going to give us the parameters for our quadratic equation. So we had correlation coefficient R, which we had for linear models. There's an R squared in our graphing calculators, which is used for quadratic regressions, and it's called the coefficient of determination. And I'll try and call it the right thing. I always want to call it the correlation coefficient. But it also tells us how well a quadratic function fits the data. So closer to 1, the better the fit. Just similar to quadratic or linear regressions. So a table shows cost of circular plastic wading pools based on the pool's diameter. I'm sure this is a pressing question for many people. I'm not sure where they come up with these examples, but find a quadratic model for the cost of the pool given its diameter. Use the model to estimate the cost of the pool with an 8-foot diameter. So this is going to be our list 1. This is going to be our list 2. We're going to put them into our graphing calculator. So here I show, remember you just press the stat button and enter, and you're going to be able to edit your lists. So here's my data. Step 2, we're going to do stat. So this is step 1. Step 2, you hit the stat calc button and then select the quadratic or quadreg model, or quadreg option. And as long as you have things in list 1 and 2, you hit enter, and it's going to do a quadratic regression. Notice this is our quadratic equation in standard form right here. And it gives us the A, B, and C to plug in to that equation to create our model. Notice the R squared coefficient of determination is very high. So this is what we got for A, B, and C. So that means our quadratic equation is going to be, and I would probably round at the 1,000th, round to the 100th actually. So, but they actually use the whole numbers. So it's going to be 2.4125 x squared minus 25.5625 x plus 67.6375. So that is our quadratic model. And now we want to predict for our independent variable. If it's 8 feet, we're going to plug 8 in for x. And it tells us it's going to cost about $49.54. So it should be pretty straightforward. Put the data in, use your calculator to get the quadratic regression model, and once you have that model, then you can make predictions for data that you don't have. So I would like you to do a quadratic regression on the real data and predict how much an 8-inch predict the real length of an 8-inch reel using that model. So that concludes this lesson. Pretty simple and straightforward. And your homework, just a few questions to practice doing quadratic regressions. Please bring any questions to class.